It is recording now. Sweet. Here we go. 6a, which is really just getting you used to using function notation, or literally instead of y equals, we're using f of x or p of x. They use p just to help you remember it's polynomial, so hence p, but you could use f, doesn't matter. Now, this form here that you're seeing, this is called a polynomial function, or the structure of a polynomial function. It looks scary, but it really isn't. What it's trying to tell you is that you will always have an x to the power of something, right? And that will be the highest power that you can have. So it could be x to the power 4, it could be x to the power 99, doesn't matter. But the next term that follows it will follow a pattern. The highest power in the next one, the second one would then be highest power minus 1. The third one would then be the highest power minus 2. The fourth one would be the highest power minus 3. And you've already seen these kind of patterns from, say, for example, quadratics. See, quadratics was ax squared plus, and you use another term, you say, well, it's b, and what's the next one? Bx. But notice x is a power of 1. And then plus c. That's your general quadratic form. And you notice the pattern here that you have something multiplied to the highest power is currently a 2. The next one drops down by 1. And the next one drops down by an extra 1, because technically there's meant to be an x to the power 0, but we all know x to the power 0 is 1. That's why we don't write that x. So that means if I want to write a cubic, so an x to the power 3, I do the same thing. I would then say something times x cubed. Now that's the largest power. Next one would then be bx to the power of 2 plus cx to the power of 1, and then plus dx to the power of 0. But since we know x to the power of 0 is 1, well, 1 times d is just d. That is the form for a cubic. Cubic meaning x to the power 3 is the highest power. But then I could have had, because polynomials just simply mean x to the power of n, means it could be any power. So I could even do, now I could follow the same pattern and say, well, what if it was x to the power of 99? Then the pattern would then be plus b x to the power of 98. So you're starting to see there's a pattern here. Then it's c x to the power of 97 plus d x to the power of 96. And you pretty much do the same thing all the way until you get to, well, I don't know what to call it. Let's, I don't know, F for final letter. Okay, so whatever that final letter is, that value of a number, that's what it is, right? So this one, you could understand what I'm writing. All they did was they summarized it with letters over here. That's literally what they're trying to say. They're trying to say something times largest power minus 1, and all the way until you get to, there's no more. Okay, so this one is x to the power of 1, so this one must be x to the power of 0. Does that make sense? Okay, so that's just the general form. Looks scary, but that's all they're trying to say. Now, I've got a couple arrows here for some key words or terminologies that I want you to fill in. The first one that you see here is called the leading term. So if they ask you or they tell you the leading term is, what they're trying to tell you is the very first term of your polynomial. Polynomial just means the function where it's x to the power of something. It could be x to the power 2, it could be x to the power 3, it could be x to the power 4, x to the power whatever it is. Okay, that's called a polynomial. Then, the degree of a polynomial, what does that mean? That power that you see, the proper name, or sometimes they call it, is the degree. Degree is the number. So this one, if it was a quadratic, I would say this is a degree 2. If this is a cubic, I would say degree 3. And obviously 99 would be degree 99. Okay, and that just represents the highest power of your current term. So the leading term has a degree of a polynomial, which is, in this case, n. Also, highest power of the polynomial function or the power of the leading term. Okay, so that's just a degree. And that helps because if you know the highest power, then you can figure out the other ones in between. Okay? And finally, we've learnt this before. What's the last term called? Anyone remember? Starts with C. Yeah. Because it doesn't have any variables on it. This is called the constant term. Okay? All right. Here's the example. Let's see if you can fill it in. I gave you below example. Let's say the polynomial function is x cubed plus 2x squared minus 3x minus 4. What is my leading term? My leading term is x cubed. Very good. Whoops, what's going on? X cubed is my leading term. Degree of the polynomial is 3. Very good, because that's the highest power. And the constant term is not x, negative 4. Very good. Okay, so the constant term is literally the very last number, the only number, hence why it's called constant, because there is no variable attached to it. So negative 4 is your constant term. So far, so good? Okay, this is exercise 6A, just getting you familiar with the language and reading polynomial function. Let's do an example. Let's have a look at this one. So I've given you a polynomial function. This is not a quadratic, it's not a cubic, it is currently a degree of 6. Okay, so you can just say x to the power of 6. I don't even know the name for it, right? We've got a leading term, which is clearly 2x to the power of 6, and the constant term is 20. Great. Your job is now to read, what does this mean? So using chapter 5, when I write it like this, p of negative 1 is equal to p of 2 equals 0, what am I really saying? What is it trying to say? Someone decipher what that's really saying to me. What is it saying? Ooh, okay. It is... Which intercept is this one? No. You were right, it's an intercept. But it could have been by luck there. What's this? If I just write p of negative 1, what does p of negative 1 mean? You got p of x, which is clearly that function over there. What does p of negative 1 mean?
Replace the x's with negative 1.
Right. So if p of x is equal to this, and that's got all the x's, then when you say p of negative 1, all it means is sub x equals negative 1 into the p of x function. So that means here, instead of it being 2x to the power of 6, it will be now negative 1 to the power of 6. Instead of it being minus x cubed, it will be now minus negative 1 cubed, plus a times negative 1 squared, plus b times negative 1 plus 20. Does that make sense? So back in year 9 and year 8, what you would have learnt is they would have said, if x equals negative 1, sub. Yeah? But now we're not going to say that. We're using notations to summarize that. We're saying p of negative 1 just means sub x equals negative 1. Then what does p of 2 mean? What's P2 mean? Sion. Yeah, just means sub 2 in. So here just means sub x equals to 2. So if I sub x equals to 2 into that function, that should be now 2 bracket, instead of x, it's 2 to the power of 6. Whoops. 2 to the power of 6 minus 2 cubed plus a times 2 squared plus b times 2 and then plus 20. But then why does it all equal to 0? What does this mean? So on one hand I say sub x equals negative 1, sub x equals 2. And why am I saying it equals to 0? What is this? What am I truly saying? Because you would have done it back in year 9. It's just that when writing as notation now. What is it trying to say? What does that mean? It is the x-intercepts. And the x-intercepts occur when y equals 0. And what you might not realize is this. When you say p of negative 1 equals 0, what you're saying is sub x equals negative 1 and the result, remember the result is the y values. Yeah, because whatever the function is, the function will have an answer. Right? This is actually just saying y equals 0. So if you put in coordinates, it's just saying sub negative 1 y0. This is what you would have seen back in year 9, which you're more used to. Okay, so they would have said back in year 9 sub that point. But we know that this point is an x-axis intercept because the y value is 0. This is the notation for it. Okay, so this is just summarizing, instead of saying sub x equals -1, and the y value will then equal to 0. It takes too long to write down. You've got to get used to using function notation. Okay, so this is revising chapter 5. P of -1 just means sub -1 into the function. Whatever the result is, that technically is your y value. It's like saying this. Y equals x squared. If I said sub x equals 2, we know that the result y should be, what would that be? If I gave you y equals x squared, sub x equals 2, then the y value should be? What's y equal to? 4. It's just 2 squared. Equals 4. But then if I ask you what's the coordinates, well, you literally just said when x is 2, y is 4. Which makes sense, because if you drew the graph of y equals x squared, when x is 2, y is 4. So that's 2, 4 there. So this is what you've been doing since year 9. Year 9, year 10, year 11, chapter 3, that's what you were doing. Chapter 5 then says to you, well, instead of writing all that, that's a lot of languages that you're using. So we're trying to simplify it. Instead of using y, we use f of x. Instead of saying sub 2, we say f of 2. And that just means sub 2. Literally the same lines. These two lines here, x equals 2 and f of 2, mean exactly the same thing. Then what do? You sub 2 into the equation, so 2 squared. The result was 4. So y equals 4. But y, if I'm replacing y with f of x, then I could have just said f of 2 equals 4. That's called function notation, chapter 5. Yeah, so in one sentence, I can say pretty much what I just wrote up here. That's what they're trying to get you to do. Yeah, and that's chapter 6, 6a. So if you didn't understand chapter 5, you couldn't do this bit. That's what 6a is trying to get you to do, getting you more familiar with function notation. Cool? All right, let's go back to the actual exercise now. So they're telling you that if you subbed in -1 into the function, the result should equal to 0. If you sub 2 into the function, it should also equal to 0. This gives us two equations. We get the first equation. Now let's go. What's -1 to the power of 6? -1 to the power of 6 gives you 1. -1 times -1 times -1 times -1. You can sit there and write it out if you want to. But that becomes 2 times 1, which is 2, minus, what's -1 cubed? -1. So minus -1 becomes +1 there. So I might as well just write it as +1. +1. And what's -1 squared times a? What does that give you? A. -1 squared is -1 times -1. So it's +1. So +1 times a is a. Plus -1 times b minus b. This is all equal to 0. Because that's what they said. They said if you sub in -1, all of that, when you add it all together, it should equal to 0. If you simplify that equation, all it is 2 plus 1 is 3. And if you move the 3 across, that's how I got a minus b is equal to, whoops, did I do that wrong? Guys, can you fix this bit? Take off the 2. I just realized I made a mistake there. Okay, because if I did it right, -1 to the power of 6 is 1, 2, -1 what times? Yeah, that's +1 is 2, +1 is 3, and then move the 3 across, so a minus b should equal to -3. Okay, yep. Oh, I didn't see the 20. No, so I was right. Keep the 2 there. Sorry, I didn't see the 20. Sorry, I missed out on this 20 here. So I was right. Plus 20 is equal to 0. And that's how I got the first equation over here. Second one, same thing. I don't know what 2... Actually, we do. What's 2 to the power of 6? Oh, wow. 2 to the power 3 we all know is 8. Yeah. 64 times 2, so double 64 is 128. So there's 128. 2 cubed is minus 8. This is now plus 4a. Next one is plus 2b, plus 20, and it's all meant to equal to 0 because we said if you sub in 2, it should equal to 0. And if you simplify this equation, 128 plus 20 is 148. 148 minus 8 is 140. And if you bring the 140 across, that's how I got 4a plus 2b is equal to negative 140. Okay? Again, you can do all this on a CAS. I'm just sort of going through the algebra so that you can see what I would have done if I did it by hand without a CAS. Okay? Now that you've got that, you've got the equations, then over here, what is your goal? You're trying to figure out what is A and B. You've got 2 equations, 2 unknowns. You can solve this using what you've learned from previous years, year 9, year 10, simultaneous equations. Okay? So it depends if you're used to substitution method or elimination. I prefer elimination method. So what I would have probably done is, that's a 2, that's a 1. So I might as well just say times this by 2, times this by 2, times this by 2. That now gives me a new equation. I get 2a minus 2b is equal to negative 46. And this equation over here is still the same. It's still 4a plus 2b equals negative 140. Using elimination method, if I add the 2 together, negative 2b plus 2b will cancel out. So elimination method, I choose to add them. This cancels out to be 0. This gives me 6a. And then what's negative 140 plus negative 46? Testing your integers now. My year 7 and 8s are doing this. What's negative 46 plus negative 140? Good. Perfect. And then from here to find A. A is negative 186 divided by 6. And you can already see there, 6 goes into 18 3 times, so it's negative 3. And then 6 goes into 6 once. A must be negative 31. But if you know A, you can find B, because the first equation already told you A minus B has to equal to negative 23. So A minus B is meant to equal to negative 23. If A is negative 31, you can move the B's across if you want, that makes it easier. Plus B on both sides. And you will get, what's this? Negative 31 plus 23 should equal to B. Therefore, B must equal to negative 31 plus 23, and that's what, a difference of 8. Negative 8. There you go. So far, so good. So what do you take out of the essence for exercise 6a? It's not about doing all the questions, it's about knowing what is the point of doing 6a. 6a, there's 2 things. 1, can you read polynomial or function notation? 2, can you work with algebra? Sub it in, simultaneous equations. That's pretty much 6a. So if you're okay with reading notations and you're expanding and solving, fine, move on. 6b is key. But if you suck at function notation, this is a good time to practice what you didn't practice in chapter 5. Okay, because chapter 5 was about you doing this. Okay? All right, team. Let's move on to the actual core of chapter 6. And this, some of you will be blown away, some of you might not. So this part here, this is where you should be watching the video for 6b. Okay? All right, 6b. I'm going to leave this part here for you guys to practice if you want, but let's look at 6b. Can I get a show of hands for a number of students who know how to do their year 7 or primary school, grade 5 and 6 long division? Hands up if you know long division. So if I gave you 302 divided by 4, not short division, but long division. Hands up. Okay. I'm going to teach, I think there's about maybe a third of you who aren't sure with long division. Whatever you do for numbers is exactly how you're going to do it with algebra. But you have to know the division first, mechanics-wise, so the algorithm first, before you do the other one. Otherwise, it gets confusing. So here we go. For those who don't know how to do long division, 302 divided by 4. this is what you do. It's slightly different to short division, but same idea. You say, how many 4s? Notice when you're dividing 4, this one goes on the outside. So how many 4s fit into 3? How many 4s fit in 3? None. So you say 0 times. And then what you do here in short division is you carry the 3 over, because that's the remainder, and then it becomes 30, right? In this case, I'm going to teach you to use long division. So to carry the 3 over, how do you make it 30? The logic is here. 4 groups of zeros, or 0 groups of 4. Now, what's 0 times 4? 0. So you would then put 0, and you say, well, what's the difference to find the remainder? That's how you knew there was a remainder of 3, and you carried the 3 over. So 3 take away 0 gives me 3. So that's my remainder, because there's 0 groups of 4. There's still a remainder of 3 left over. And then you drop down the next digit. This is how you get your 30. This is your long division instead of short division. Yeah, so short division, we just carried the 3. Long division makes it clear. Now you ask the same question again. How many 4s fit in 30? How many 4s fit in 30? 7. So you know that 7 groups of 4, what's 7 groups of 4? What's 7 times 4? 28. So then you write 28 clearly. So you know 7 groups of 4 gives you 28. And then to know the remainder, you would subtract the 2. So 30 take away 28. We know there's a leftover of 2. That remainder in a short division, you would have carried over to the 2 and it becomes 22. Instead of carrying it over, we now drop the 2 and you ask yourself again, you then say the next step. How many groups of 4 fit into 22? And you say 5. So you say here 5 groups of 4. So 5 times a 4 gives me 20. Find the difference to know what the remainder is, because you're always finding that amount of remainder. In this case here, I've got a remainder of 2. Your answer then means 302. So I'm just going to draw it on the side here. 302 divided by 4, or another way of thinking about it is 302 over 4 is equal to 75 wholes, because that's how much it fits in. That's your quotient. Okay, so that's what's left over in wholes, and a remainder of, so plus an extra remainder of 2 out of 4. This is how you would have wrote your mixed fractions back then. So you would have wrote 75 and 2/4. Yeah? 75 and 2/4 literally means 75 wholes plus 2/4. This is your quotient. This is your remainder. This is no different. What I just wrote here in a number sense, we're not doing anything different. We do algebra. Same concept. Okay, so just following those steps, this is the key part that you're going to get used to. And then we're going to get 2 different answers. Okay, you're going to get a quotient, and then you're also going to get a remainder that's going to look like that. Okay, let's have a look. I'm just going to move this to the left a bit to keep it neat. All right. Oh, that looks terrible. Sorry, I'll just fix that again. I'll keep it. All right. Let's do this one now. So here's your algebra. Let's have a look at this one. So you are given x cubed minus x squared plus 3x plus 4. This is your 302. That's equivalent to you writing 302, like what we were doing before. Yeah? And then we said 302 divide 4. This is your 4. So x minus 1 is your 4. So the 4 is meant to go on the outside. So you're asking how many of these x minus 1s fit into this cubic equation? Just like how we said how many 4s fit into 302. Same idea. Yeah? Now, the pattern works exactly the same way. So here we go. we're saying how many of these x minus 1s can fit into x cubed? Now that feels tricky, right? But the same way, just like before, we said something groups, a number of groups of x minus 1 should get you as close as you can to x cubed. So you're saying, what would I write here that when I multiply to x and also multiply to negative 1, I will get x cubed? Now let's just start off. Just ignore the negative 1 first because that's an x and that's an x. What would I have to write here so that when it multiplies to x, I get x cubed? X squared. Logically, I need an x squared because x squared groups of x will give me my x cubed that I want. But remember, when you multiply x squared, you've got to multiply to both of these terms. It's like saying x squared times x minus 1. When you expand the brackets, x squared times x is x cubed. X squared times negative 1 minus 1x squared. Can you see what I'm doing there? So I'm just writing exactly the same things that you would have done over here. You said 0 times 4, then I'm doing x squared times x minus 1. 0 times 4 gave you 0. So I wrote x squared times x minus 1 gives me x cubed minus 1x squared. Find the remainder. How do you find the remainder? Subtract the top and the bottom line. So here we go. Let's subtract them. What's x cubed? Take away x cubed. We know that it's going to be 0. Here's your next line. Be careful here. Negative 1 of these x squares minus another negative 1 of these x squares gives you what? So I'll write it out more clearly so you can see. Negative 1 of these x squares, take away negative 1 of these x squares. What does that give you? No, that's where the mistake happens. Double negatives. What does double negatives do? It's plus. So it's like saying negative 1 of these x squares plus 1 of these x squares. If it helps you, just take off the x squares and just look at it as negative 1, take away negative 1. Yeah? So if you're struggling with your integers, write it out without the letters. Negative 1, take away negative 1. This is what you would have done back in year 7. Yeah? So negative 1, take away negative 1 is the same thing as saying negative 1 plus 1 at 0. So this actually works out to be 0, negative 1, take away a negative 1. This is where most students make a mistake because of the double negatives there. That gives you 0, and then what do you do next? I've got 0 remainder, but then I can still move down the next term. This now becomes 3x. That's a positive 3x there. Then you say the same thing again. You ask yourself now, how many groups of x minus 1 will fit into 3x? But notice, you're just really multiplying what multiplies to x to get you 3x. What number multiplies to the x to ensure I get close to 3x? 3. So here I would then write positive 3. Positive 3 times the x gives me positive 3x. But don't forget, when you're multiplying it, you also have to multiply the negative 1 because you're saying 3 times x minus 1. So when you expand the brackets, you get 3x minus 3. Now in this example I wrote, it happens to have 2 terms. Well, then you do have a constant term up here. We can actually just bring it down to make it more clear is what we can do. Okay? So when you find the difference, in the next line, what's the remainder? 3x take away 3x. Well, it's 0. The 4 is my constant. 4 take away a negative 3 is 7. So what's my answer? This is I've done all the terms. We don't go into decimals. That's my remainder. So if I write my answer is the quotient when you're dividing x cubed minus x squared plus 3x plus 4, and you say divide by x minus 1, you know it fits in x squared plus 3 wholes. That's my quotient. Plus my remainder. And what's my remainder? It's 7 over x minus 1. Just like you did over here, you were dividing by 4, so it's all in terms of fractions of 4. So quarters. So that's why your remainder was 2 out of 4. Then here is 7 out of x minus 1. This is your remainder. This is your quotient. How's that feel? Bit tricky? That's 6b. That's what I mean. I want you to practice 6b. You have to get good. In your study design, this is the first skill that you need. There's a lot of other ways that your tutors could teach you. There's a synthetic method. There is division by inspection. Synthetic you guys will like much more than this, but you have to learn this skill because synthetic has limitations. Okay, so I'm going to teach you this first because you can apply this to many. And if your algebra is strong, then you can do division by inspection and it's quicker. Okay, but it does require that you can do it in your head. So I'll teach you division by inspection soon as well. But for today, we're just going to do polynomial division and I'll show you a bit of synthetic so you can see how easy it is. Okay, but don't rely on synthetic. At some point, you're going to be stuck on it. Okay, here we go. Let's do one more. One last example. Try this one. Here we go. So we got 2x cubed minus 2x squared plus 3x plus 1 divided by x minus 2. Here we go. I'm going to call out some names and you're going to guide me through this. Okay? First step. You're asking, what do I multiply to x minus 2 to get as close to 2x cubed? What would that be? Can I please have... Let's go with Adi. What number would you put here? 2x squared. So because we know that 2x squared times x will give me 2x cubed. Don't forget, you're also going to multiply to that negative 2 as well. So 2x squared times negative 2 is negative 4x squared. Great. What's the next step? After you've multiplied it, and you've got the number of groups, what do you do next? Can I please have Numafi? What do you do now? Very good. You find the remainder. What's the leftover? So you want to see how many times it fits in. There has to be a remainder. Subtract them. 2x cubed take away 2x cubed is always going to be 0. And then be careful the double negatives here. Negative 2 take away a negative 4. What's negative 2 take away a negative 4? Let's go with Mete. Yes, you're right. That's positive 4 and that's a take away 2. So it should be positive 2x squared. What's the next step once you got the remainder? What do you do next? Can I please have, let's go with Luke. Have a look at the notes. Yeah, bring it down. Okay, so after you finish the remainders, you move on to the next digit. So here, same thing. The next digit is 3x, positive 3x, so drop it down. You now have plus 3x. And then you start the algorithm again. You say the same thing. Someone else now, Kai. What do I multiply to x minus 2 to get as close to 2x squared? What would I put there? So something multiplying to x to get 2x squared. What would I multiply?
2x.
Yeah. So there, I would then write positive 2x, because positive 2x groups of x will give me the 2x squared. But then don't forget, you also have 2x groups of negative 2. 2x times negative 2 is minus 4x. Then what do you do after this? So after you've multiplied it, Sion, what do you do in this step now?
Minus 2x squared minus 4x.
Beautiful. You find the remainder. So you saw how many groups it fits in. Well, then what's the leftover? Subtract them. So 2x squared take away 2x squared. Notice it's always 0 because you're always trying to match it. This will always be 0. You're only finding this one. 3 take away a negative 4. 3 take away negative 4 is 7. Very good. So this should be 7 of these x's. And then what's the next step? Can I please have Ben? What do you do next? Very good. That's your next digit. Bring the 1 down. You got a plus 1. And you start the algorithm again. You ask yourself, what do I now multiply to x minus 2, which really just focus on the x, what do I multiply to x to get 7x? What should the number be? 7. So the number here should be positive 7, because positive 7 times the x gives me my 7x. But don't forget, I also have 7 groups of negative 2, which is negative 14. This is how many times it fits. So then I need to then subtract, just like I have been. Oh, what's going on? Just like I have been to find the remainder. Notice this will always be 0, because you're always matching it. 0, and then you just figure out, well, what's 1 take away negative 14? It's 15. So what's my answer? The quotient is, when you do it, the quotient is 2x squared plus 2x plus 7, and there's a remainder. What's the remainder? It's 15 out of? Very good. It's what you were dividing by. This is your quotient. This is your remainder. So the next few exercises, our goal is to find a factor, something that you divided by, so that you don't have a remainder. If you have 0 remainder, you can then factorize this from chapter 3. That's when you can solve. That's 6C, 6D. Okay? But you have to be able to figure out when you get a remainder, when you don't get a remainder. Okay? All right. Copy those notes just so you can see the pattern. And then now I'll show you the quicker way. But there's a limitation to it, okay? So don't rely on this skill. It's nice to know, but don't rely on it. I hate it when students rely on it and then they make mistakes everywhere. Yeah? Here's method 2. Method 2 is called synthetic division. You'll like this one. This is how it works. Shh. Listening? You take, because the algorithm, there's a pattern here. Can you see the pattern? 0, 0, 0. The only thing you focus on is actually the second column. Because of that, they decided to say, well, how about this? Ignore all the letters and just focus on the coefficients. That 2, negative 2, 3, and 1 is written here. 2, negative 2, 3, 1. So it simplifies the whole algebra component part. Next part. Where does 2 come from? Well, since you know you're always subtracting, okay, because you're always going to always multiply that number to the 2. 2 to the 2, 7 to the 2, right? So you're always multiplying to this 2. It's always groups of 2, right? So they say, well, since you're also going to subtract it, double negatives is going to be positive. Or another way of thinking about it is, you know how I taught you moving left and right from a turning point form? If you let x minus 2 equal to 0 and solve for x, whatever that number is, you put it on the outside. It's just to counteract that double subtraction component. Okay? So here's how the algorithm works. This is where I got the 2 from. I got 2 from the x minus 2. So if it's minus 2, then it becomes positive 2. This is how it works. The first number, have you noticed in both examples, whatever's here is always going to be there. True? Whatever the first number is, it's always going to be on this first line. So what they do is they say, well, take this 2, drop it down, because it's always going to be a 2. And then how do you start it off? This is the pattern. Because you're always doing this times that to give you this number, and then this times that to give you this number. Then they say, well then, just take that 2 times that 2. So here we go. We write down times this. Whatever the answer is, pop it over here. What's 2 times 2? 4. The positive 4 goes here. It's a positive 4 because it's 2 times a positive 2 gives you a positive 4. Now, do you notice that's a minus 4 there? But remember, when you're doing a double negative, minus a negative actually becomes a positive 4. That's what this plus 4 is. And then what you do here is you say negative 2 plus 4 gives you 2. So now I do the same thing here. Negative 2 plus 4 gives you positive 2. And then you follow the same pattern again. Take the outside number multiplied to this 2, and then pop it over here. Because that's pretty much what we're doing. We're just doing the same thing. Instead of going down, just go across. So here we go. What's 2 times 2 again? 4. But it's a positive 4. But if you look at it again, do you notice right here? Minusing a negative 4 is the positive 4. That's why it's there. And then you would have done positive 3 plus 4. That's pretty much what I'm doing here. Positive 3 plus 4 gives me now positive 7. What do you do next? Follow the same pattern again. The pattern is you're always taking that group of 2 times the 7 and then pop it over here. 2 times 7 is 14 and it's a positive 14, but notice it's exactly what I did over here because it wasn't by chance I get a 14. It was I take the 7 times the 2 and I get that 14. Where'd the 7 come from? What was this first number? That's where I'm getting it from. That's where the 7's coming from. Right? So 7 times the 2 is 14. And then 1 minus a negative 14 is the same thing as saying 1 plus 14 is 15. Now, what do these numbers represent? This is, and how do I know that this must be a quadratic? That it's 2x squared plus 2x plus 7, and therefore this must be my remainder of 15 over x minus 2. How do I know this is going to be quadratic? Because this is one of the limitations of this technique. How do I know that this 2, 2, 7 is quadratic? Anyone see where the hint is? Because why wasn't it linear? Why was it quadratic? What's the hint?
Is it like the order they're in, like in 6A? There's like 1, 2, 1.
Yeah, because think about it. What did I give you? I gave you, what's the leading term of the expression I gave you? What's the leading term? Over here. What's the leading term? 2x cubed. This here is an x cubed. Who cares about the number? I know it's a 2 at the front of it. But what am I dividing by? X minus 2. But notice the x again. This is an x to the power of 1. Now logically, if you took a cubic and you divide it by a linear, x cubed divided by x, what are you going to get? X squared. That's why I know the form has to be a quadratic. And then using the polynomial pattern, we know that it's x squared, then it becomes plus x, and then plus constant. That's one of the limitations of this technique, is that you had to realize it was cubic divided by a linear. So then that's why you end up with a quadratic. What's the limitation is that if I gave you instead, let's say a 3x cubed plus 2x squared, and I said divided by, instead of a linear, what if I said divided by x squared minus 1? So you can't do that now. If you want to use synthetic division, it won't work. This is the problem. Even though I know the answer is going to have to end up being a linear, because you're taking a cubic and you're dividing by a quadratic. Cubic divided by quadratic should give me a linear. Your synthetic division can't do that, but your polynomial can. Okay, so some of the limitations to the synthetic division is it can't do anything that's not linear, but it also can't do another thing. You know what it can't do? If I gave you 3x cubed plus 2x squared and I said divided by 2x minus 1. See, if you do the method I showed you, you'll be doing the opposite of minus 1, which is positive 1, which is not true. If you use the technique I taught you, you would have said x equals half, which is on the right track, but if you actually do the calculations, it won't come out true. Synthetic division has a lot of limitations, and you have to know when you can use them. Let's have a look at when you can use them from your textbook. Here's your textbook. You can use synthetic division. That's a cubic divided by linear. All good. Doesn't have a number in front of x. Doesn't have a number in front of x. It's linear. Cubic. Fantastic. All of this works with synthetic division. All of this works with synthetic division because you've got cubic divided by linear. Cubic divided by linear. That one also works too. This one doesn't work. Can you see this one? Cubic divided by, yes, this is linear, but it's a 2x plus 1. If you do a bit of tweaks to the algorithm, you can make it work, but it's a limitation. Okay, so I don't want to teach you the tweaks to it because then it's more things for you to memorize. But I'm just telling you when can you use it, when can't you use it. Can't use it here. Can't use it here. 2x plus 5, 2x minus 1, 3x minus 1 doesn't work. Okay, you're going to make an error if you use synthetic division. If the question was asking dividing by a quadratic, if you're dividing by a quadratic, won't work. If you're divided by anything else but a linear, won't work. That's why you have to learn polynomial division. Synthetic will be useful for certain cases. Okay? I'm going to pause there for today. There was quite a bit to take in. If you were to practice today, I would say start off with 6b and pick a few. Pick a few, try it, check your answers, see if you're on the right track. Okay, you've got two methods there to check, and I'll show you a CAS next session. How to check with your CAS calculator as well. All right, team, thank you. Like I said, 6B, 6C is going to be tricky, so take your time.